We are going to be discussing how Python handles object-oriented programming. So we're going to be taking a look at classes, objects, and inheritance. And we are going to start by reviewing some object-oriented programming terminology. A class is basically a blueprint for creating objects. So you are defining uh, different properties or features of the objects and what actions can occur. So the class itself is conceptual. Um, Nothing has been created. It's basically an indicator of what you want to create. Analogy is if you receive a prescription, okay? The prescription is an intent for medication, but it's not the medication itself, right? So class is kind of the same thing, right? It's what we're planning to do when we create the object. Hey, you can also look at it like a cake recipe. You have your ingredient list, and then you have your actions that you have to take in order to make the cake, but it isn't the physical cake itself. Okay, so those are a couple analogies that you can use for class. When you create an object using your class, you are instantiating the class. So you're basically creating something using that blueprint. A single object is one instance of the class. So when you create an object from the class, the object has an identity. So in your computer, it's going to be assigned a memory address. It has a state, which would be the data that it's storing. And then it has different behaviors. So the behaviors are defined by the methods, which are little functions. So as the program runs, the state will probably change because you are going to be executing different methods. And those methods are the actions that are being taken, and they're typically actions that affect the data. So as you take different actions, the data changes, and that causes the state to change. An attribute is just a variable that is part of the class. So when we create a class, we create variables to store data. Those are called attributes. We create methods, which are just functions that manipulate that data that you are storing within the class. So the functions are called methods, and they create, modify, and delete class objects, and they manipulate that data that is part of the class. Polymorphism deals with method overriding and method overloading. In Python, we have method overriding. We don't really have method overloading. Most languages do have method overloading, but in Python, it's more overriding. And you'll actually see that today when we do inheritance. Encapsulation hides the details of the class from the outside world. And this is kind of a cornerstone of object-oriented programming. When you create your class object in your code, you'll have some variable, you'll assign it to new, and then whatever your class name is. And all of the inner workings going on are hidden from you. So all you know is, if I have, let's say, a store class, and I have a variable called my store, and I set that equal to new store. All I know is I end up with a my store object. Unless I wrote the class, I don't know what's going on behind the scenes. Okay, and it's designed that way. Okay, so encapsulation is hiding those details from me. And I can use the class, and I don't need to know how everything is coded. Abstraction is achieved through encapsulation, so they kind of go together. It is the process of hiding the real implementation of an application from the user. So when we are using built-in classes, right, we don't actually go into the code to see how that class was written. What we're concerned with is, how do I create an object? How do I call the methods? And that's what we need to know. What are the different properties I can change? Okay, so that's all part of abstraction, okay, where we're just kind of focusing on how to use the application rather than, how was this thing created? Inheritance is when you basically reuse code. It's kind of awesome if you don't like to do a lot of typing. Once you have a class that works really well, if you have another class that you want to develop that is similar, you can reuse the code in the existing class, and you do that through inheritance. So basically, you pull all the code from the existing class into your new class, and then you can customize that new class by adding attributes and methods. Okay? And you still can use the existing class attributes and methods. So you just have to add the new stuff to it. So it's actually pretty awesome. And you are going to see how that is done in Python later on today. We are going to start with the very basics though. So creating and using classes. As I mentioned when we were talking about terminology, classes contain attributes and methods. So attributes are the data that you're storing, and methods are the actions that are taken on that data. In Python and in most languages, classes are typically created in external files, and they are imported into your program. For simplicity's sake, when we start out, we are going to put the class information at the top of the program file, and we're going to put our code below it. At the end, you will see how to separate the class information into modules, separate files, and how to import them. Okay, but we're going to start very simple to begin with. So to create a class, all you need is the keyword class, followed by whatever name you're going to give it. And one convention in Python is to capitalize the name of a class. So we start with the keyword class, and then we're capitalizing the first letter of the name of the class. And if the class has more than one word, you can camel case, which I've illustrated here with class name, where you capitalize the first letter, and then for the second word, you capitalize the first letter. If there's a third word, you capitalize the first letter. That is camel case. You can also use underscores between words. So, you can use whatever you feel comfortable with. Below the class name is where you put the attributes and the methods. And by default, everything in Python is public access. So coding and calling methods works very similar to coding and calling a function. In fact, we use the def keyword when we create functions, and we use that same keyword when we create methods. So the main difference between a function and a method is that a method is inside a class and a function is not. So a method requires a class object to invoke it or call it, whereas a function does not. One method that is automatically called when you create an object is a constructor. And in Python, the way they create the constructor is a little different than other languages. So to create a constructor, it is 2 underscores, init, 2 underscores, and a left and a right parentheses. And constructors are used to set your attributes to initial values or starting values. In all methods, the first parameter is self. And self refers to the object. So in a constructor, this is the object that you are creating. So if I have my store equals new store, it's automatically going to go to this init constructor and initialize the attributes that are in that object. So it's referring to the object that I'm actually creating. In all the other methods, self refers to the current object that is calling the method. So if I use the myStore object to call a method, self is referring to myStore. It's whatever object invoked the method, okay? So every method is going to have the keyword self. It is the very first parameter in the method definition. So the syntax here, as I said, you start with def, a space, 2 underscores, init, 2 underscores, and in parentheses, the very first parameter is self. And then any other attribute that you have in the class needs to be included in the parameter list. And so you're just using self dot, whatever the attribute name is, you set that equal to the attribute that is in your parameter list. Quite often, what you have in the parameter list matches the attribute names. And so you get something like this example, where we've got name, description, and specialty. Those are the attributes that are in my class. Those are the names that I chose for the parameters. So it kind of looks like you're repeating yourself. So I've got self.name equals name, self.description equals description, self.specialty equals specialty. Name, self.name, self.description, self.specialty are referring to the object I'm creating, and name, description, and specialty are attributes defined in the class. Okay. The ones that we are assigning that are on the right side of the equal sign, those are the values that are getting passed. Okay, so this is a constructor simply used to initialize values. And then you can see here I have a method. Okay, so if it's not the constructor and it's in a class and it starts with def, it's a method. Okay, so the very first parameter has to be self. In this case, it is only self. And self is the current object. So the current object has the name, description, and specialty attribute. Okay, so those attributes are all part of self. So if I wanted to print out the specialty in the name, all I have to do is enter self.specialty and self.name. okay, because self contains those attributes. And I did put a side note here that if you wanted to set a default value of zeros or spaces, you do not have to have attributes passed to the constructor. And another thing you can do is you can set up the attributes to have default values so that if nothing gets passed, it'll use the defaults. And setting default values in a method is the same thing as sending them in a function. You just set, like I do, name equals space, description equals space, specialty equals space. And to do a space, it's just double quote, or null. Here's another example of a class called trip. And you can see that the constructor is receiving location, destination, and total miles. You'll also notice that I have another attribute called miles traveled, which I'm just setting to 0. Now, could I have included that up in the list here and set miles traveled equals 0 up here in the parameter list? Yeah, I could have. Okay, because remember, whether it's a function or a method, if you have a default value in the parameter list, then passing the value is optional. So all of the rules that you guys learned for functions as far as passing data, setting up defaults and all of that, they still apply to methods. So creating and using class objects. So we talked so far how to create a class. We looked at the constructor method, init, and we took a look at another little print method. Now we're going to look at how to create and use a class object. There's basically two different ways that you can set up the syntax. You're going to have an object name for your variable, whatever you're going to call it. You're going to set that equal to the class. And then in parentheses, you are going to send it those arguments. And you can either set it up horizontally or you can set it up vertically. Quite often with classes, I do see them set up vertically. But for the hobby example we were looking at, I've got 2 hobbies. Each one is an object, right? Hobby 1 is an object. Hobby 2 is an object. Hobby 1, you can see I have set up the argument list horizontally. And for my second hobby, I did it vertically. This kind of comes down to personal preference. However, if you have a lot of parameters, it is easier to set up vertically than it is horizontally. I personally like vertical because to me it's just easier to read. Because I can look on the left, I can see the attribute, I can see the values. To me, that's super easy to read. So both of these examples are going to create the objects using the init constructor. So this data gets sent to the init constructor. And you'll notice that the second example, I am using the attribute equals. So in this, the order that I pass does not matter. In the first example, it does matter, okay, because I am not using the attribute in this example. So it's going by position only. So either one of these will create the object. Then, if you want to access an attribute, because everything is public, All you have to do is take your object, a dot, and the attribute. Okay, so if I want to access the name from hobby1 or hobby2, it's just hobby1.name or hobby2.name. If I want to call the print specialty method, because this is a class, I must prefix the method call with my object and a dot. So it's hobby1.printSpecialty, and hobby1, that object, then gets passed. Let me find where that method is. That object gets passed into this method. So self is referring to hobby1. So when we print self.specialty and self.name, this is the specialty and the name from hobby1 because hobby1 is the object that called the method. Okay, and for hobby2, it's the same thing. When hobby2 calls that method, then I'm going to print the specialty and the name from hobby2. If you want to delete objects or attributes, it's actually super easy. You're going to use the del command for delete. And if it's the object, it's just del space and whatever your object name is. If it's a property or an attribute, it's del space your object, hobby1 or hobby2, dot, and then the attribute. And then it'll be gone. So we're going to skip over the practice because there's separate videos for that. And we are moving on to modifying object attributes. So there's 3 different ways to modify the value that is stored in an attribute. You can modify the value directly through the object. And you can see how that works. That's just the object name dot attribute equals, and then you just assign a new value. So if I wanted to, change hobby2, I could say, well, I think it was running before, I could say hobby2.name equals weight training. And then I change the description and the specialty as well. Okay, and that's all you have to do as far as modifying using the object and the attribute. You can also set the value using a method. So basically, you call a method to make the changes. And then the third way is, and this works if you have some kind of an attribute that is a counter, okay, that's keeping track of things. You can actually increment a value in a method. So we're going to look at the 2 ways to use methods to change your attribute values. So modifying attributes using a method. In this little example, we have a class called trip, and you can see in the Init Constructor that we are assigning location, destination, and total miles based on the object that was created. That information is getting passed to us. And then you can see that we have another attribute called miles traveled. And miles traveled, we are setting to 0. Okay, and then we've got another method called new destination. New destination is similar because we're changing the destination and the miles, and we're still setting miles traveled to 0 because now they're going somewhere new. And so this example shows how we are changing values, destination and total miles, through a method. Okay, and how this would look in your code would be something like, do you want to enter a new destination? Y for yes. We check it, and then we pull in where they're traveling to, and then they've got the miles for the trip, and we pass those along, and that's how they get set. One little adjustment I did have to make in the trip example is I basically convert the value, the numeric values that are being passed into either integer or float before I store them. To me, this is a good practice to get into in the class itself because you don't know if the person using the class is having someone input a value or if they're just passing a hard-coded value. And anything that is input is considered a string. It is not a number. And if you're going to do any kind of arithmetic on your attributes, you need to make sure that the value you are storing is a number. And so doing this little conversion will account for any way the user is going to enter the data. So I'm covered and I know that total miles is going to be a number. Okay, so that's one thing I want to point out because eventually you guys will be creating your own classes and that is something that you need to think about. So we've covered how to directly modify an attribute in your main program code, how to modify through a method where you just are assigning the attribute a new value. And now we're going to look at modifying attributes through a calculation. So in a method, we're going to calculate a new value and assign that to the attribute. So in the book, they have a car example, and then they have a update odometer method. Okay, and so what this little method does is it checks to see if the mileage is greater than the odometer reading. And if it is, then the mileage gets updated. If the mileage that they want to use is less than the odometer reading, that's not legal because they'd be rolling back their miles. So we're printing out a little error message. Okay. In that particular example, here is the line of code that is calling update odometer. The object is my used car. And you can see there's a dot. And then here's the method being called. And the values are being passed. Now you're going to say, okay, that's a really weird way of writing 23,500. Remember that the underscore is being used instead of a comma. Okay, so it's just a way to help the person entering the value enter it correctly. Could they have just done 23,500? Yes. Okay, but this helps people. So instead of putting in a comma, they just do an underscore. And if you wanted to see the full-blown example, this is the example from the book. And here is the full-blown trip example. So we've talked about init, and here you can see that I have made some adjustments here. to ensure that values are stored as numbers. And I've added a default value for miles traveled up here. So that makes it optional. And then I've got a couple new methods, one called get miles, one called update miles. So get miles just figures out how many miles are left. So it returns the total miles minus the miles traveled. Okay, so that tells them how many miles they have left on their trip. And update miles traveled accepts a miles argument. So we're passing miles and we're adding it into the miles traveled. Okay, so this is an example of using arithmetic basically to update an attribute that is in your class. Okay, and then here's the main part of the program where we are accepting input. And remember, all of these then are considered strings, which is fine for your starting point and your destination, but that is a bit of a problem for the miles because that needs to be a number. Okay, so this line, trip equals lowercase trip equals capital T trip. This is my object, lowercase trip. Capital T trip is my class. I am passing it start, destination, miles. It's going to run through the constructor where it takes the location and assigns it, assigns destination. You can see I'm handling the miles here. So I am making sure it's going to be an integer that gets stored. And then we did not pass the miles traveled, so it's just going to take a 0 and put it in there. Okay, and then I'm setting a variable called go, and then I'm getting how many miles we have left. And at this point, when you first start, you got your whole trip left. So get into a little while loop, and we're going to stay in the loop as long as we have miles left and the user does not want to quit. So we first ask if they want to change their destination. And if they don't, then we just ask them how many miles they've driven today. You'll notice I'm doing a conversion here. Now, I wouldn't need to do that because I am converting in the class. However, if I didn't write the class, I wouldn't know that. So I'm just making sure that it gets converted. And then I'm passing that along to update miles traveled. Okay, and then I'm printing out how many miles are left. And then I am assigning the miles left to the variable left, which is what I'm checking in my while loop. And then I'm also getting a new value for go. So, assuming they don't want to quit, we go through this again. Okay, and we'll keep in the loop until there's no miles left or they decide they want to quit. So this is something that you guys can certainly copy and run. And let me pull up my practice. And hopefully I don't get any bad. Sometimes when you copy and paste, you end up getting non-printing characters, which causes problems, but I don't think that's going to happen. Where am I traveling from? Where am I traveling to? We'll go somewhere warm. I'm thinking it's 2,000 miles. How many miles did I travel today? All right, so then I could say, do you want to continue? Yeah, I'm just going to press enter. No, I don't want a new destination. Let's do 1,000. 500 to go. Do I want to quit? No. Do I want to do a new destination? No. So let's say I did 600. Negative 100 to go. Do I want to quit? And it's just going to exit me out because now my miles left is no longer greater than 0. As you can see, it's negative 100. So, maybe I might want to edit this a little bit. So let's see here. I'm getting the miles left. I mean, I could do something like if left is less than or equal to 0, right? That's true. Print. You've reached your destination. Break. Okay, and then that would get me out. So we can try this again. All right, let's just say that we've gone now over the mileage. And so now, and it's still printing negative miles. I could probably change that still, but it says you've reached your destination and it's done. But you guys kind of get the idea. And we're going to skip over hands-on 2 because there's a different video for that one. And now we are moving on to inheritance. So you've seen how to do a class. And for inheritance, it basically lets you create a new class based on an existing class. So the class you inherit from is called the base. It's also called a parent class. Some languages like Java will refer to it as a superclass. All the same thing. It's the one that you are inheriting from. The new one that you're creating is called a derived class. It's also called a child. Some languages will call it a subclass. The terminology in our book is parent and child, although you should be familiar with these other terms because a lot of sites use them interchangeably. Okay, so I do see base and derived quite often, and I see parent and child quite often. So how do I create a child class? You still have to use the keyword class, followed by whatever you're going to call your child class. And in parentheses, you tell it the name of the parent class. So in this little example, I have a person class, very simple. And I'll tell you, most parent classes are pretty simple. So here I've got self, which is the object I'm creating, first name and last name. And the only method that's in this class is one called print. Then I create a new class called student. That student class is based on person, which means that it is going to include first name and last name and any new attributes that I assign it in this new class. So in your Init Constructor, you actually have to pass all of the attributes that the parent class needs, plus you have to pass the attributes that the child class needs. And so how that looks is you've got self, and then you've got the parent attributes, and then you've got the child attributes. And you'll notice, and I'm not sure if I mentioned this, on that line, you always have an ending colon. Then the attributes that belong to the parent have to be passed along to the parent constructor. There's 2 ways to do it. There is one method where you can use the parent class name. The other method, you just use the keyword super followed by a dot. The super constructor basically gives you access to everything in the parent, and that is typically how it is done, and that is how we are going to do it. So the advantage of using super is that you're going to inherit all the methods and properties from the parent. And then coding wise, the difference, not only instead of using the parent class name versus super, the other thing that's different is if you use the parent class name, you have to pass self. And if you use super, you do not. Okay, you just pass along the attributes that it needs. So there's a few little differences in coding, and there's differences in accessing. So taking a look at our little example, we've got our student inherited class. And you can see that we are passing along the first name and last name using super. And then the student class itself only has year, the year attribute. But in our print, we still have access to the first name and the last name that are in the parent. Plus, we got access to the year. And in your program, you can create objects from student or person. Okay, so in this little example, I'm creating a student object. So you'll notice that I included a year here. And when I use that student one object to call print, well, it knows it has a student object, so it calls the appropriate print method. In the next example, I'm creating a person. And so I'm not passing a year. And when I go to print, it's smart enough to know, hey, I got a person object now. So I need to go through the print method for person. So basically, when an object is calling a method and you have inheritance, it's going to look at what type of object it is. And then it is going to call the appropriate method. That is a feature that is built in. How to handle lists in classes and how to create a list of objects in the main program. So when we talk about lists, we're also talking basically about dictionaries, okay? Dictionaries, tuples, lists, they're kind of handled the same way. And because Python is loosely typed, you can include those in the arguments that you pass. Okay, and Python will figure out the data type based on what you're passing it. So in this little example, you can see that I am having them enter the name of a store, the merchandise sold, the number of customer transactions. I'm creating a little list. Right now it's empty. And then I want them to enter the items that they purchased or a queue to quit. And so as they're entering items, I'm adding them to this temp item list. And then once we are done, once they've entered a queue, this is where I'm creating an object. So the class is called specialty. The object is called sales. And I'm passing it name, type, customers. And then for items, I am sending it the temp item list. Okay, and so it wouldn't matter if I sent them one variable or a list. Okay, Python's smart enough to know that when it brings it in, that it's now dealing with a list. So this is a similar program, but they're going to be allowed to do more than one store. So how many stores are you entering? They are going to key in how many stores they want to enter. We have a listing of stores. Okay, and then we get into a while loop. So we print out sales summary information, enter the name of the store, the type of the merchandise, the number of customer transactions. Then we've got that little item list where they are going to be adding items that were purchased that day, adding them to the list. We're creating a sales object here. And then you can see that we're actually using the sales object to call a method called describe store. We're using the sales object to display the items that they entered. And then we're taking that sales object and we're adding it to the store list. Okay, we're adding one to a counter here. So if they wanted to do 5 stores, our store list would end up with 5 store objects. So it would have 5 objects in that list. Okay, and then if we wanted to access that list, that store list, and print things out, we could do that in a for-in loop. So in a for-in loop, S becomes our object because everything in store list is an object. So we can use S to call describe store, we can use S to call display items, and it'll just whip through the list. So here is the full-blown example. So you can see we have store. That is our parent. And we have specialty store, which is our child. Okay, and so you can see that we've got the name, the type, the daily sales, which we initialize to 0, so that's optional. And then we have a describe store method. We have an open store method. We have a set daily sales and increment daily sales method. And then down for items, the only thing we really have is display items. So this part you guys have seen, but let's run it. Okay, so how many stores? Let's do 2. Enter the name of the store. Pam's Pets. Puppies. Let's see. Let's say we had 1 transaction. A Maltese puppy. That was all they got. All right, so it's showing what was purchased. And so you can kind of see, if you follow along, enter the name of the store, merchandise sold, customer transactions, the items, created the object. It did describe store. Okay, Pam's Pets is a puppy shop. The following items have been purchased. So that is coming from display items. Then it added the sales into our list. Okay, now it wants the next store. So let's see. Trudy's Treats. Snacks. Oh, people like snacks. Let's do 200 transactions. Enter the types of items. Candies, cookies, chips, dip. Now we'll quit. Okay, so here you can see that we got the output for Trudy's Treats. So that would be here and here. it added it to our list, and then we ended up falling out of the while loop, okay, because we said we only wanted to enter 2. So then we get into this for in loop, and that is where this printout is coming from. So basically, we add 2 objects. So it does the printout for the first one, and then it does the printout for the second one. Okay, so that's pretty much how we are handling lists. We can pass a list to a class, and in our main program, we can store our class objects in a list. Adding other class objects as attributes within your class. So what you can do is if there is an existing class that you want to use and store data in, you can add an object as an attribute within your own class. So to show you how this works, I took the miles and made a class, and then I've got my trip class. And in my trip class, I do want to have mile information. So I do want an attribute with mile info. And I have to set that equal to the miles class. And so here's where I do that. So I still have location and destination. And then I've got an attribute called mile info. I set that equal to my miles class. And my miles class, you'll notice I set up with default values. So I don't actually have to send it anything, but I am passing it total miles. So it's going to initialize the total miles, but the miles traveled and the miles left are being kind of set for me. So mile info, that attribute is going to contain total miles, miles traveled, and miles left. Okay, so that is kind of the weird thing about putting a class object in your class as an attribute. That attribute is going to contain the attributes from the other class. So to access those attributes from the other class, you're going to have to go through mile info, which is kind of weird. So if we look down here at new destination, you can see that we are pulling in destination and total miles. And so here, setting destination is pretty straightforward. But for total miles, basically what I'm doing is I'm just calling miles again and passing it total miles. So I'm just basically resetting the whole thing, which makes sense, right? Because if your total miles change, well, then the miles traveled has to be reset to 0, and the miles left has to be changed as well. So in your program, how do you update the miles traveled? Well, this is how you would do it. Ask them how many miles they travel, store it, make sure it's a number, use your object, and then you have to use the attribute for the other class, because that attribute, in this case it's mile info, that contains all of the data for the miles class. So I'm using trip, I'm using mile info, and then I'm actually calling update miles traveled, and I'm sending it miles. But I have to use the current class object plus the attribute representing the other class in order to call update miles traveled, which is part of that other class. So to print how many miles I have left, how would I do that? Same kind of concept, right? So trip is our object. Mile info is the attribute from the other class that contains total miles, miles traveled, and miles left. So if I want to access anything in the miles class, I have to go through mile info. Okay, so that is exactly what I'm doing. I've got trip, which is my object, dot mile info dot miles left. So this is my revised program. Now the book has a similar example showing a car and a battery class, but I'm going to go ahead and copy this. So the only thing that you really have to keep straight here is anytime you want to do anything with the miles, you have to go through mile info. So you have to use your trip object dot mile info dot, and then if you're calling the method, you'd have, dot update miles traveled, parentheses, you're passing it miles, or if you are modifying one of the attributes, it's going to be trip.mileinfo dot, and then whichever attribute you're modifying or accessing. And then you'll also notice down here, which is a little weird. So for the new destination, if I wanted to get total miles and miles traveled, you'll notice here, self is referring to the current object. So here I've got to use self dot mileinfo dot total miles, and self dot mileinfo dot miles travel. That's just because inside the method, I'm not using the object name. The object called the method. So self kind of becomes an alias for that object name. So I have to use self.mileinfo. Okay, so we'll go ahead and run this. It runs very similar to the way it ran before, but you can see that how we set it up is totally different. So this is actually, if you hadn't seen how the classes were set up, you wouldn't know that they were separate classes. Okay, so that's all part of abstraction and encapsulation. Okay, so just looking at how it runs the exact same as it did before. Okay, you would not know any difference. So at this point, we have talked about how to create classes, how to use the Init Constructor and how to create different methods. We've talked about how to create class objects. We've talked about how to handle passing lists or dictionaries or tuples. We've talked about how to store the objects in a list. And we've talked about how to set default values. And we've also talked about creating a class where one of the attributes is actually an object from another class. What we haven't talked about is how to take the class and put it into its own module. And so that's what we're going to cover next. And so if you have something like miles and trip, Really, how you would set this up is that miles would be in its own file and trip would be in its own file. Okay, so um, normally at the top of each one, you will have some documentation. The documentation is called a doc string, and it starts with 3 double quotes, then whatever it is that you want to tell people about the class, what its purpose is, what data gets passed, whatever is relevant. It can be on multiple lines, but you need to remember to end the doc string with 3 double quotes. So it starts with 3 double quotes. It can span multiple lines. It ends with 3 double quotes. And you can see in both these examples, I added the doc string to the top. Okay, and in this case, I put them both in the same external file, but if I wanted to, I could have put them into separate external files. Okay, so this is showing them in one. And I should say, whether you put them in one or in two, it just depends on, do you think people might want to use the miles without trip? If you think that people may want to use these independently, you can put them in separate files. So how do I pull in a class when it is saved to a separate module? Well, there's a couple different ways to do it. Probably the best way is the standard method where you would say from. This is the name of the file, and you don't put .py on the end. You just do the file name. And then you say import, and then you tell it which classes you want to pull in, because a single file can have several different classes. So you are being specific about which ones you want to pull in. And, once you do that, nothing else in your program has to change. Okay? Everything else works the exact same. And so here's another example where I've got a store class that I put in a store file. I've got a specialty class, which is actually inherited, but I put that in a separate file. So I have a store file and a specialty file. And then my main program is in a file called My Store. And you can see that I'm importing store from the store file and specialty from the specialty file. And then nothing else has to change. So to me, that is the really easy way to modularize, right? So if I think I've already done this in here. Now let me see if I have the example. Okay, so here's store. And here's specialty. And let's see, here's my store. None of this code in the main program had to change. I just had to add these 2 lines to the top. Okay, so super simple in modularizing this stuff. Now, there are other ways of importing classes. You can just say import module name. So basically, remember your module name is the file name. So if I did it this way, initially I had from trip miles, and I told it which classes to import. If I just import basically the file and I don't tell it what classes, then when I create my objects, I have to put the file name in front of the class. So here I had to change this line. I did have just trip and passing it start, destination, and miles. Trip is my class. But because I changed how I was pulling in the information, now I have to prefix trip with trip miles. Okay, everything else is the same. It's just now I have to tell it, hey, inside the trip miles file, what class am I going to use? Now, this next method, I'm mentioning it. This is not something that you should ever use. It's considered bad programming. But instead of importing specific classes, you can import asterisk, which imports everything. This is bad practice because unless you created the module, you don't know what's in it. And some of the classes and some of the things in that file could conflict with your own code. So that is bad practice. It is bad programming. It is not how we are going to import our classes. But you could see this out in practice. It is lazy programming, okay? So, somebody might think they're being smart doing it that way, but it can cause a lot of problems down the road. Another thing that you can do is create an alias. So you can import your file, give it an alias, but then you're still going to have to prefix the class with that alias so it knows what class you want to use. Because basically, even though you're giving the file name an alias, you still haven't told it what classes you're going to use. So this still does require a prefix on the class. And like I said, the first methods that I showed you, where you are telling it the name of the file and you're importing the name of the class, this is how you should be importing your classes in Python. So to give you a little practice, Hands-on 4 is going to have you modularize some of your exercises. And we will talk about that in a little bit, but that is pretty much all you need to know about classes, objects, and inheritance.